last week is we took something like just a general quadratic that wasn't factorable, and we made it a perfect square. Yes. So like we did something like x squared plus 6x minus, I don't know, let's say 20 equals 0, right? And we couldn't solve it because we can't factor it, right? And so what we did is we changed it into a perfect square. And so in case you forgot, we moved this number over to the other side first by adding it, right? Remember that? Yes? Edgar, you good with that? Okay, Edgar, and then what you had to do is you had to take half of that, remember? And you'd square it. So half of that would be 3. And you'd square it. But if you add it to one side, you also have to add it to the other. And then I was trying to help you guys by telling you not to square this one. Because your next step, right, is to factor. And whatever number that is right there, it goes right here. And this would be 29. Well then, yeah, so we'd solve it, right? From there we were solving. But there's other reasons you complete the square. But yeah, from here we were solving. And so you would like take square root of both sides, right?
No, b over 2 squared equals c.
And so then x is negative 3 plus or minus the square root of 29. Yeah? That's what we did? And so, square root of 29. Let's see here. I wonder if I got a calculator button on this thing. I don't. Here. Let's see what the square root of 29 is. Approximately. Oh. 5.4. We'll say 5.4, okay? So square root of 29. So on a side note, we'll say square root of 29 is approximately 5.4. So the first thing I need to show you guys today is how to get approximations to this, because what we're going to be doing, Ivan, is we're going to be making graphs. And one of the things we're doing when we're solving is these 2 points right here, these x-intercepts, we get them from this. Yeah? So Edgar, that plus or minus right there, right?
Yeah.
That's why you have 2 answers.
Yeah.
Okay, so now let's say that, like, let's use this approximation. So here's how I do it. You can do it all kinds of ways, but this is the way I kind of keep it organized. I separate them like this. I do one that's the plus, right? And I do one that's the minus. And I do it just like this. And I've never seen a student that did it like this that forgot one. When you do it just as random scratch work, it's easy to mess up. But I do the plus and then I do the minus. So that would be what? Like 2.4? And this one, negative 8.4. Those would be your 2 x-intercepts. What? So that's what you missed. It's a lot, right? Or no? Wait, Ivan, were you here? You weren't here on last Thursday, right? Were you?
Ivan?
No, he wasn't. It was. Yeah, well, you weren't here. Did you do these? Do you remember this? No, you weren't here. That's you weren't here.
Yeah.
Okay.
Yeah.
All right.
I wasn't here.
Okay, so what's that, Edgar?
Oh no, I was just going to tell him. Like this is like I write down the quadratic formula. Y esa es la otra formula, the easier formula. This is the formula we're using to finish.
Yeah, the quadratic formula comes from this. But there's other stuff that comes from this too.
B over 2 squared equals.
There's other stuff that comes from this too that's not the quadratic formula. So you got to know how to do it anyway. So check this out. Here's what we're going to do today. All the examples we did last week, a was equal to 1, like this one, right? Now we're going to do it where a is not 1, and that's where it gets kind of ugly. Yeah, that's where it gets kind of ugly. So let's start one. You ready? It's gonna be fancy. So let's do one that's like let's say, hello, Mr. Flowers. Let's do one that's 2x squared minus 5x minus 12 equals 0. let's do this one. So we're going to complete the square. And it's tricky because that's not 1. Right? Man. In fact, we're going to solve to complete the square. So I'm thinking. So here's what I'm trying to figure out how to show you, okay? There's 2 reasons we're going to complete the square in this class. One is to solve, and the other is to like change it to this thing called vertex form. Like this, right? We're not going to learn that until after our quiz, but we are going to learn it. And depending on what it is you're trying to do, solve or change to this form, sometimes changes your first step, well, your second step. Regardless, your first step is still the same. Move the 12 to the other side, but leave yourself room. So you're adding 12 to both sides, right? Okay. Man. So here's what you're going to do. You need to get rid of this right here. This A number, you got to get rid of it. And the way you're going to do that, we're going to divide everything by that number, which is going to be a little different than how we're going to do it here. But I guess I'll just show you how we're going to do it for solving. So here's what we got now. We got x squared minus 5 over 2x equals 6. We all good? Edgar, the steps aren't any different. They just get kind of ugly because we have a fraction, right?
Is this one still from last week?
Saying nothing's different. Only thing's different is that 2.
It's just that the way you did it.
Yeah. So now we still take half of this number.
But it's not the A, x.
Yeah, we're not working on that yet. But for this one, when A is not 1, we do something a little different. It just looks different. And I was thinking about showing you that today, but since we're not going to learn that for a couple weeks, I thought it might confuse you. Well, actually for a week. We're not going to learn this for a week. So I thought that might confuse you. So I'm just going to show you the solving part. And so all you're going to do is you're going to move this C term to the other side first, right? And then you're going to divide by A. So here's what we're doing. We have ax squared plus bx plus c equals 0. So this is like how we do it, right? We first move c to the other side. You good? That's what we did right here in red. Yeah? Okay. And then we divided everything by A. Is that okay? Like do you see? This is what we did right there. And this is what we're doing right there. Okay. Now, the reason you leave space right here is because, do you remember, Jose? Remember you take half of that b term, you take half of it, you square it, and you add it to both sides. So if I'm looking at negative 5 over 2, and I want to take half of that, that's going to be negative 5 over 4. Would you agree? So I have to take and add negative 5 over 4 squared to both sides.
So it's b over a, right? On the right side, we put x squared plus b over 8x equals...
Over here? Yeah. And here, you don't worry about this yet. Don't worry about this yet on the right. It'll be there. But I want to make sure you don't get confused by where these numbers come from.
Yeah, actually, where do those numbers come from?
Which one? This one right here, 5 over 4? Because what you do every time is you take half of this b term and you square it and you add it to both sides. So half of 5 over 2, half of 5 over 2 is 5 over 4. But we never square it on this side, but we always square it on this side. So I did in orange like how I like did the generic, right? This is going to be pretty cool. I'm excited about this. I mean, it is Halloween, right? And, you know, scary math's appropriate.
You're scared about this math problem?
Oh, I'm not scared about it. I'm happy, right? I'm happy. I don't know why in haunted houses they don't have like a math classroom, you know? Like, you know, you walk through all these scary scenes and settings and whatever. They never have a math class. Imagine if you like walked through a haunted house and it was like all brightly lit and it was just like somebody teaching you fractions.
Homework sheets.
Right? Pop quiz at the end. Okay, Edgar, now check this out. This part over here, we're going to factor it. And every single time, this number goes right there. That's what we saw last week. We saw that like over and over and over again. That's the shortcut. And that's why you do not square it. Because if you squared it, then you're going to get confused when you have to factor it. That's it right there. That's it right there. And we could square this out, and we could see we would get x squared minus 5x. We get x squared minus 5 halves x plus 25 over 16. If we multiply that, squared it, we would get this. You want to see it anyway, Mr. Flowers, to make sure? You're like, if you don't believe me? Do you want to see that this factoring equals this right here, in case you don't believe me?
I believe you.
You believe me? You don't want to see it? It actually works out pretty easy.
But I like to see it though.
Okay, let's see it. Let's do it. Let's do it right here. X minus 5 over 4 times x minus 5 over 4. Okay, you ready? So the first two make x squared. No problem there, right? The outside, 5 over 4x, yeah? The inside, right here, is negative 5 over 4x. And the last two, 25 over 16, right? That's 25 over 16. Check this out. X squared, and that's minus 10 over 4x plus 25 over 16, and that can be reduced. That is equal to 5 over 2. So it's true. All right, now we got to get a common denominator. I don't know what 16 times 6 is, so I'm going to do that over 96. I believe you. So this is going to be, do you see how I did that? Yeah, because that's what 6 equals is 96. I just got a common denominator. 96 and then 25. It's been a long, really rough day. 121? Let me make sure. That's 11. Carry the, well, yeah, 121. So 121 over 16. Woo. Dang. All right. So in green over here, the generic thing, right? Without any numbers. Here's what happened. Remember, we factored this. Right? And that's the shortcut. And then over here we got a common denominator. So that's what we're going to do over here. Do you see what's missing? This needs to be 4a squared. This part right here needs to be 4a squared. So what I need to do is I need to multiply this by 4a over 4a, right? And so what I'm going to get is I'm going to get negative 4ac minus b squared, plus b squared, right? But I don't like the way that looks. And then on the bottom we do have 4a squared as the common denominator, because that's a times 4a. It's 4a squared, and that's already 4a squared. I'm going to switch this so that the minus sign's in the middle. And the only reason I'm going to do that is it's harder to mess up. It's harder to lose that minus sign if it's in the middle. Okay? So that's all I did, is I just cleaned that up. And again, just to make sure you guys understand, all we're doing is for every single step of this example, we're doing like a generic one with just A, B, and C. Like A is 2, B is negative 5, and C is negative 12. That's all we're doing, right? So you can't do the calculation over here. We can do the calculation over here. What's next? Do you remember if we're going to solve? Solve for x. Do you remember what's next? You guys are hurting my feelings.
So yeah, just doesn't make x equals to that.
Square root?
Mm-hmm.
So, square root, right? So x minus 5 over 4 equals the square root of this. Isn't that plus or minus 11 over 4? Because the square root of 121 is 11 and the square root of 16 is 4. And remember, there's a plus or minus. Yeah? So over here we would do the same thing. We would take the square root of both sides. So you get x plus b over 2a equals, now this is where it gets a little tricky. This numerator, it's all in a group. We could do the square root of b squared if it was just b squared, but we would have to subtract 4ac from it first. So I don't know what that is. So it's going to be b squared minus 4ac, all divided by the square root of 4a squared is 2a. You see I took the square root of the denominator, but the numerator, I don't know what that is. Last step, well, almost, is we have to add this to both sides. Right? We have to add that to both sides. So it's going to be x equals 5. And you see they both have the same denominator of 4, so I can write them as one fraction. And there we go. 5 plus or minus 11, all divided by 4. And I could do the same thing over here. I could subtract this, and you see they already have the same denominator, which is a good sign, because that means we're probably doing it right. And so when I subtract b, I get minus b, and then remember plus or minus the square root of b squared minus, hate my life, that's a minus. Man, all that beautiful work, and then I mess it up because I was writing in pen, and I was going to write the 4. That's b squared minus 4ac divided by 2a. That's the quadratic formula right there. It comes from completing the square.
Well, that's a pretty long way to do it.
Well, you wouldn't do this every time,
Yeah.
but this is how it was discovered.
Yeah.
That's like the shortcut, because this is what happens every single time. Now let's find our two answers right here. Remember, there's one plus, right? So 5 plus 11 divided by 4, and there's one minus. 5 minus 11 divided by 4. So that's 16 over 4. And this is negative 6 over 4, which reduces to negative 3 over 2. So those are our two answers for the example we did. So you might be wondering, well, why didn't you just give me this formula, and why do we have to do all this?
So you can know another different way.
Well, the reason why is because there's more reasons to complete the square other than to solve. There's other stuff. There's other stuff for this class, and there's other stuff for college algebra, which you're going to take next. Because there you're going to do these things called conic sections, like circles, and yeah. Anyway, you have to know how to complete the square to do those equations. It's really not that hard, completing the square, but it's something that it can be overwhelming, especially if you missed like the first day. Right, Ivan?
It's not hard. I get it, but it's pretty much a long process.
Well, it is now. It is now, but at first it's really short. And it's really the same thing, it's just the numbers get uglier. All right. So, wait a minute. Edgar, have you ever seen where the quadratic formula came from like that? Did you ever seen like complete the square for something like this, and then you end up with that formula?
No, they always tell me just to do the...
They just showed you the formula, right?
Yeah.
But that's where it came from. And it's really cool, because it took people a long time to figure this out. Like, as a species of, as human beings, it took us a long time to find this.
Yeah.
And then once we found it, then we could build bridges, and then pretty soon iPhones. It's all connected. All right, so I think you guys should try one.